Welcome to Coding Foundations for ESAPI. Here we're going to discuss C# essentials for new developers or maybe new programmers to C#. I'm thrilled to have you on this journey to dive into the fundamentals of programming, explore powerful features in Visual Studio, and learn the essentials of C#. Whether you're entirely new to programming, returning after a break, or just looking to expand your skill set, this course is designed to build a solid foundation that will pave the way for your future work with ESAPI. Over the coming sessions, you'll discover how simple programming concepts like variables, classes, methods, and control structures can come together in real-world applications. We'll walk through setting up your development environment, writing and debugging code, and even building a basic application that brings these concepts to life. Our approach is a hands-on, practical, supportive approach, ensuring you gain both the confidence and skills you need to start your programming journey. So let's get started and unlock the potential of ESAPI together. Welcome aboard, and let's code our way to success. We have a few objectives for this course. First and foremost, we want to understand the basic fundamental concepts of programming. This includes exploring things like variables, data types, classes and methods, properties, and how they apply to coding. We'll also look and navigate the Visual Studio environment. This development environment is powerful and feature-rich, and it's really going to be your second home for building ESAPI applications. We also want to master C# syntax and structures and build a foundational knowledge for learning how to write code in C# and .NET Framework, and also prepare you for integrating this knowledge into the Eclipse Scripting API. Establishing a solid base for programming is going to make the Eclipse Scripting API much easier to learn. In this course, we intend to start with a basic programming tutorial introduction. Then, once we move forward, we'll get started with C# and Visual Studio. We'll take a look at the basic programming constructs such as variables, classes, methods, loops, conditional statements, all of the above. Then we'll build on compiling simple applications and get a sneak peek at how we can later integrate this into ESAPI. So why start with this Coding Foundations for ESAPI? Well, a couple of things that we hope to address is helping users get started who maybe have no prior programming background. Or maybe you're like many physicists and you have some prior programming experience from your university days and you just haven't really been programming all that much over the past years. This course is built to help you gain confidence in using these modern tools, enhance your programming coding skills, and prepare you for the Eclipse Scripting API Introduction course. As our clinics become more complicated and more technology-driven, automating certain tasks and workflows is going to be an important part of any clinic's toolkit. In this short online course, we're going to first look at the fundamentals of programming. We'll move to a tutorial on how to set up your development environment, including Visual Studio. Then we'll look at another tutorial of C# syntax and control structures. We'll move to a hands-on portion for the course where we're going to build a couple of applications using C#. And then finally, another tutorial on how to take that knowledge we've gained from C# and apply it to the Eclipse Scripting API. There are many additional tools and resources at your disposal, such as development tools like Visual Studio, which now comes pre-installed with GitHub Copilot, and other AI programming assistants such as ChatGPT, Claude, or Gemini. There's other learning materials out there, namely the Gateway Scripts programming courses, some Variant-provided material on the variantapis.github.io, and also open source projects that you can take inspiration from on GitHub. In the community support page, there is an ESAPI subreddit, as well as the Variant Innovation Center at developer.variant.com, where you can ask questions to experts all around the world as you continue your journey with Eclipse Scripting. So how can you get the most out of this course? This course is meant to be taken before the Eclipse Scripting Introduction course offered by Gateway Scripts. The Eclipse Scripting Introduction course expands in detail on each of these topics that we touch, as well as more programming examples directly using the Eclipse Scripting API. Find any upcoming courses on the Gateway Scripts website. Then after you take the ESAPI Introduction course, you'll be ready for more advanced scripting, such as the Gateway Scripts automation courses or application development courses, and the ESAPI Foundation courses on YouTube can help you prepare for those more advanced courses. Now let's get started looking at C# and some of the programming syntax that goes with it. Hello everyone, and welcome to our first module, Fundamentals of Programming, Understanding the Building Blocks of Code. I'm delighted to have you here as we begin our journey into the world of programming. Today we'll start with the very basics, grasping the core concepts that every programmer needs to know. Whether you're completely new to coding or returning after some time away, this session is designed to build a solid foundation that will serve you as you progress. We'll explore essential topics like variables, data types, operators, classes, and control structures. So let's dive in together and start unlocking the power of code. In these upcoming slides, we'll discover what is programming and why are programming fundamentals important. The topics that we'll cover will include variables and data types, operators and expressions, classes and methods, as well as control structures that can help you build code to accomplish your task. Think of programming as requesting the computer to perform some specific task. Something like writing a recipe where you have step-by-step instructions to achieve a desired results. The idea behind programming is that we use a programming language, in this case C#, to communicate those instructions to the computer. Within a programming language, you can create variables. Variables are containers used to store data. In the example below, the variable called age is being used to store the numerical value 25. There's also data types. Data types define what type of data can be stored within a variable. In the example below, we have variables that are of type int for integer, string, and bool for Boolean values. This program allows us to store, manipulate, and retrieve information as we need it. In the example below, you can see the console.write line is displaying the information to the user about the age, name, and whether or not this particular person is a student. C# is a strongly typed language, which means that every variable and object must have a defined type at compile time. This is essential because the C# compiler needs to know exactly what kind of data it's working with so that it can allocate the correct amount of memory and enforce type safety. For example, when you declare a variable as an int, as seen below, the language ensures that only integer values are stored there, and if you attempt to assign a value of a different type, it will result in an error. This strict typing helps prevent bugs and make your code more predictable and easier to maintain down the line. When we look at operators, operators can be arithmetic operators, such as addition, subtraction, multiplication, or division. They can also be comparison operators. In C#, if you want to check whether or not two values are equal to each other, you would just use two equal signs side by side. If you wanted to check if two values are not equal to each other, you can use an exclamation mark and then the equal sign. Less than and greater than signs can also work for numerical comparisons. If you want to compare multiple conditions together, you can use two and symbols or the two pipe symbols to represent an and an or, respectively. And combinations of these variables and operators can be used to help compute a value. In the example below, we see three integer values coming from A, B, and C. And in the result, we're checking two conditional expressions to check if A is greater than B, which in this case it is, and whether or not C equals 17, in which case it is as well. When writing code, it's important to make sure that you write clear and understandable expressions. It's often helpful to use parentheses even when they're not necessary to help avoid ambiguity for yourself or anybody else reviewing the code. Also consider the type of each variable to ensure that the operations make sense in context. Digging deeper into the basics of programming, we come across classes. Classes are basic blueprints for creating objects. Remember we talked about object definitions such as integers, strings, booleans. In C# you have the ability to make your own type of object. To the right you see a class that's defining a person. So in the definition for a person, we have two properties, one string property for name and another int property for age. Underneath, we're using some code to instantiate a person class. So now we have an object called person that is of type person. And we're setting the name and age. We're setting the name to Bob and the age to 30 and requesting that the code displays the info of the person. Encapsulating classes in this way can be very useful. For one, you as the developer get to control how the data is accessed and what methods are available to the data. It allows you to also control the maintainability of your application. If you wanted to add some properties to the person or some methods, you know you have one class file that has all of this information available inside. When you're building classes, think about how you can detail in the code real-world objects such as a person or a patient or something like that. The idea here is that you can abstract an idea into some code and then build the functionality of everything that you would want related to that idea into the class file itself. This is going to allow you to hide the complexity of what it means to be a person in this example. And the users of your application, they generally aren't very interested in how the class itself is built out, but instead they may just want to know the age of a person when they look them up by the name. Each class also has the ability to encapsulate methods. Methods are functions that are inside the class that perform some specific task. They can manipulate data, perform calculations, or do anything else that the code can actually execute. Here in this example, we have a class called calculator. And this class called calculator has a single method, and you can see that the method's return type is an integer. The method is called add, and the add method takes 2 integer input arguments. In the code below the class definition, you can see that the calculator class is instantiated as a variable called calc, and then on that calc variable, you're allowed to call the method with a dot operator at the end of the word and put in the 2 required arguments in order to perform the calculation. And finally, we move on to control structures. The first control structure we'll look at is the conditional statement. The conditional statement most popular use is the if, else if, and else conditions. In this example, we have an integer variable of a score that equals 85, and we have an if statement, and we note that in the if statement, the condition itself is wrapped in parentheses. And here we have a check that says if the score is greater than or equal to 90, we're going to return an A. If you want to add additional conditions to this list, you can use the else if. So here, if the first condition is not true, it will then look down to the else if and check the additional condition, which is the score is greater than or equal to 80. At the very end, you can use the else keyword. The else keyword is there in case none of the other conditions are satisfied and you still want to return some value to the user. So here we're writing to the console the grade C if the score is not greater than or equal to 90 and also not greater than or equal to 80. So anything less than 80 will return a grade of C. There's another special type of conditional statement called a ternary operator. If your condition is such that the true statement will return some value and the false statement will return a different value, you can use this operator. In the example at the bottom, we have an integer variable of a score that's equal to 78. Here, we're trying to determine the grade based on that score. And the condition we're using to use that is if the score is greater than or equal to 80. Now, if that condition is true, meaning the score is greater than or equal to 80, the true part of a ternary operator gets returned after the question mark. If in fact that grade is not greater than or equal to 80, the false part, which here is needs improvement, gets returned after the colon. So in this example, because the grade is not in fact greater than or equal to 80, it would return needs improvement. Another type of control structure are loops. In C#, there are 2 distinct types of loops that are supported. The first is a for loop. Inside of a for loop, we generally create a variable, in this case an integer, and we set it equal to some value, in this case 1. After the first semicolon, we put the condition by which the loop should continue executing. So here, we're going to continue the loop until I is no longer less than or equal to 5. And after that final semicolon, we put what happens to this variable as the loop iterates. In this example, we have I++, which means that I is going to get an additional integer added to it each time the loop iterates. So I will go 1, 2, 3, 4, and then 5. After the iteration, when I becomes 6, the condition for which the loop exists will no longer be satisfied, and the loop will stop on its own. A for each loop is a special type of loop that iterates over a collection. In the example we see a string array, and this is how we create an array with the open and closed brackets. And the string array has 3 strings inside called apple, banana, and cherry. The for each loop, we create a variable of an object type that matches the object types inside of the collection, and we also give that variable a name to be used inside of the loop. You can see the syntax here for the for each loop. Let's say that with all of our newfound C# knowledge, we build some functionality that's extremely useful, and we want to use this functionality over and over and over again. Well, there is a way to do that built into the way that these applications work. So let's say that I create a class, as you see on the left, called Math Helper, and that class has some very useful methods such as being able to double a number by multiplying it by 2 or calculate the area of a circle. I really like these methods and I want to use them over and over and over again. Well, I can take this class and I can compile it into a DLL, which stands for Dynamic Linked Library, and that will create a referenceable library for any new projects that I create. So all I would have to do in my new project is add the new library that I've just compiled as a reference to any new project. Then when I want to use that library inside of my new projects, I will first reference the library by referencing the namespace with a using directive. And once I reference that namespace with a using directive, I'm free to use the classes and methods inside of that library. So in the example, since I'm referencing the myUtilities namespace, I can then access a math helper, which I call a variable of helper, and then I can access the methods from that math helper. The developers at Microsoft have built many libraries this way. In the .NET framework, you have many ready-to-use libraries that have namespaces at your fingertips. These libraries don't require any additional compiling because they're built in to any popular C# project template that you have by default. For example, we see at the top screenshot a using directive for system.io, which stands for input-output. In the example, you can see that this class called file is being used to write text as well as read text. That file class, which has a method called writeAllText and readAllText, exists in the system.io namespace. So by referencing that namespace, we're able to leverage functionality of prior Windows developers. In the example below, we're using the system.link library, link standing for Language Integrated Query. We have a variable called numbers, which is a list of integers from 1 to 5, and using the link library, we are able to extend the functionality of this list to add a method to it where we can search the list based on conditional expressions. And in this example code, we are searching the list to find even numbers by checking that the number inside of the list modulo 2 equals 0, and the where method will return each time that condition is true. There are many benefits to utilizing the standard .NET framework libraries. It's going to speed up development since you don't have to reinvent code pieces. It's going to reduce bugs because you're tapping into community-tested code from professional developers. The programmers at Varian built the Eclipse scripting API the exact same way as we've discussed before. ESAPI is just another .NET framework DLL. You reference the vms.tps.common.model.api and the vms.tps.common.model.types libraries the same way you would reference a custom library that you create by yourself that we would see a couple of slides ago. Then after your project has those libraries referenced, you can include a using directive for those libraries, and that will give you access to all the Eclipse scripting API features. If you use the Eclipse script wizard, those libraries are included as part of the template. So you don't really have to think about it, but this is how it's working in the project. This is beneficial for a couple of reasons. One is you're going to get access to strongly typed Eclipse objects such as plans, patients, and structures. And from that library, you can see the properties and methods that are available to those classes. It's also going to expose methods that are tailored to Eclipse workflows, such as calculating the DVH, creating plans, or calculating dose. Next, before we move on to build some applications with C#, we should first discuss how to install Visual Studio and some of the features built into the Visual Studio Integrated Development Environment. So let's take a moment to discuss our developer environment. In this next section, we'll take a look at some of the different ways you can set up your development environment, including the introduction of one of the most popular development tools out there, Visual Studio. Setting up a developer environment is critical to success with clinical scripting. Beyond having a safe workstation that will not risk accidentally corrupting or modifying patient data in your production environment, the development environment offers an opportunity for developers to develop code, test, document, and deploy code efficiently from one workstation. The premier implementation of development environments is to have a dedicated system responsible for clinical programming and testing. One of the major benefits to a developer environment is having a system that can be put into research mode. This is a mode that's not suitable for clinical environments wherein automation scripts can be deployed into the Eclipse treatment planning system without prior script approval. Physical T-boxes can also be used for script development. Physical T-boxes are nice because you can immediately test the scripts on the Eclipse treatment planning system that's installed on the T-box, although you might be sharing that T-box for different purposes, such as testing algorithms and testing new features in the Eclipse treatment planning system. Additionally, personal PCs can also be used for Eclipse script development. They are easily available as everybody likely has one, but the downside is that you don't have Eclipse installed in order to easily test these scripts, which means that the scripts that you build will have to be transferred to an Eclipse system in order for testing. Before we continue discussing the Visual Studio integrated development environment, there are a couple notes of safety that we need to mention. When Eclipse treatment planning system is installed in your clinic, there is a customer technical bulletin available, which is listed above. In that customer technical bulletin, they list Eclipse as a Category 3 medical appliance. And in that same document, it stated that third-party applications except for antivirus software shall not be installed on workstations or servers hosting Category 3 products or applications. Additionally, there's a list in the customer release notes for each version of Eclipse that include all the different third-party softwares that can be installed on a Varian Eclipse workstation. Visual Studio is never referenced in these customer release notes, meaning that Visual Studio is not to be installed on a clinical Eclipse workstation. Additionally, developer environments can be set into research mode, which allows for automation applications to be tested without the prior script approval. Clinical production treatment planning system environments should never be set into research mode, as it can hinder the ability to treatment approve plans that are modified with scripts. This could have a very negative impact on your clinical workflow. Visual Studio is the standard for integrated development environments using C# programming and .NET framework development. Visual Studio can be found by searching the web for Visual Studio or by going to visualstudio.microsoft.com. There are 3 different Visual Studio downloads available: Community Edition, Professional, and Enterprise. Community Edition is available to those who intend to use the Visual Studio integrated development environment for open source development, education purposes, including academic research. Be sure to discuss with your institution's licensing office prior to installing Visual Studio on any computers that belong to them. When installing Visual Studio, the Visual Studio installer is the first to open. In order to develop in the C# programming language for Eclipse Scripting API, the .NET Desktop Development Package must first be installed. After installing the .NET Desktop Development Package, the Individual Components tab of the Visual Studio installer can be used to ensure that you have the correct version of the .NET Target Framework. If you're working in Eclipse version 15.6, you'll need the .NET 4.5 Target Framework. If you're working in the ESAPI 16.1, you'll need the .NET 4.6.1. And if you're working in ESAPI version 18, you can use the .NET 4.8. When installing a new version of the .NET framework, there is both an SDK and targeting pack available. They have different responsibilities, but it's best to go ahead and install both. Once you have Visual Studio installed, you can begin to use Visual Studio for the development of your C# applications. Using Visual Studio includes knowing the different components available in Visual Studio and where different tools exist. One feature of the Visual Studio IDE that you will be using a lot is the Solution Explorer. The Visual Studio Solution Explorer allows you to navigate through all the different files of your project, including references and properties within the project. The vast majority of the real estate in the Visual Studio IDE is the text editor. This text editor includes semantic highlighting that gives hints to what different types of objects are based on the color of those objects, and a just-in-time compiler, which will show red squiggles or green squiggles underneath text to show any errors in syntax that you may have written in your development. During your script development, it may become time to compile your code. Compiling the code is as simple as clicking on the Build menu at the top of Visual Studio and clicking on Build Solution. The Project drop-down menu can also bring you to the project properties of the application that's currently loaded in Visual Studio. These project properties include the .NET target framework, which is important to match the target framework version of the Eclipse scripting API that you're programming against. Another important property to ESAPI development is the platform target. The Eclipse scripting API libraries are built on an x64 platform target, requiring any script that you develop to also be built on an x64 platform target. Finally, source control within Visual Studio is very simple as it's UI-based instead of console-based. Using the Get Changes tab in Visual Studio, you can navigate your source control management solutions, such as creating new repositories, committing code to those repositories, creating and merging branches, and pushing and pulling from remote repositories. Source control management in Visual Studio is a breeze. You can track different versions of your code as you commit and make changes to your code. If you have your code in a remote repository, it's very easy for collaboration with others, backup and recovery of your projects, and overall it makes your projects more professional in the development process. When working in source control, there are a few key terms that you may want to commit to memory. One is a repository. The repository is a centralized location where the code and the history of the code development are stored. These repositories can live locally on the hard drive of the computer that you're working on or in the cloud. Once you've made changes to your code and you want to create a snapshot of the changes that you've made at a given time, you can then commit those changes, which in turn allow you to track specific changes over time and allow you to revert back to older versions of the code. If your repository is linked to an online repository, such as in GitHub, you can push the code up into the online repository, or you can pull the code, which fetches the new code changes that could have been made on a different workstation or by somebody else, and brings them into your current project that you're working with. In order to maintain the integrity of your code when making bug fixes or adding new features, a branch can be created which creates a parallel version of your code. Once that branch has been tested and approved, you can merge that branch back into the version of the code that you intend to deploy to your clinic. Finally, if you're working with code that's available in an open source context, the clone feature allows you to pull code from an online repository into your Visual Studio instance so that you can review, modify, and deploy that code on your own. Visual Studio includes additional tools for integration with Git source control management. It allows you to manage the source control from all the features we've discussed previously, but also includes tools for looking at different changes in the code between each commit and resolving conflicts when you're merging branches from online repositories or for different local branches. It's important to remember that a well-understood development environment boosts your efficiency and reduces your potential to errors. It's important to know the tools that you're working with, such as Visual Studio, which again is a powerful IDE for .NET desktop development, including knowing where the Solution Explorer is, the output window, and the debug console. It's also important to understand the basic concepts of source control, which is essential for version tracking, collaboration, backing up your code. All of these features are integrated into Visual Studio to make them easy to use and assist developers in streamlined workflows. Before we get started with direct ESAPI development, let's take a look at the C# programming language and some of the features of the .NET framework.
In this first example, we'll use Visual Studio to explore some of these C# concepts by building a console application. First, we'll launch Visual Studio and choose the option to create a new project. There's many different types of projects that Visual Studio supports, So I'm going to search console and look for the console app. I want to choose the console app that has the .NET framework in parentheses. This is an older version of Microsoft provided .NET technology, but one that's tightly related to how the Eclipse scripting API works. I'm going to create a project with the name Calculate Math, and I'll put this somewhere in my operating system so I can find it later if I need to. So I'm going to put it in this code examples folder. You can do so as well. Then, once I've got all my settings correct, I'm going to click Create. This will create the console application for me. With the console application created, Visual Studio will display the code inside of the code's text editor window. You can see the initial code doesn't have much code here, but it has a namespace that matches the name of the project and a main method that is the starting place for the project. So for this example, let's just create a couple of variables. So the first variable I want to create is an integer. So I'm going to start with the keyword int. And I'll say int a equals 5 to assign a value to that integer. You'll notice this green squiggle underneath the A. That's simply telling my compiler that I'm not using that variable. That's okay, because we're going to use the variable in the next line of code. So after creating another variable, b equals 7, I'm going to create another final integer object where I'm actually going to use a and b. So let's go ahead and use the console object. So to use the console object, there's a hotkey in Visual Studio called console.writeLine. In console.writeLine, we can put text into the console, and in this example, I'll say a plus b in the text, and then concatenate that string with my own variables a plus b. You'll notice that now the using directive with system is now bolded instead of this kind of grayed out color. And that's because the console class is actually coming from that system namespace. And remember, all the using directives that we have at the top of the code require a reference added to the project that contains those namespaces. To run the project, I can simply click Start at the top of the IDE, and you'll be able to see my output to the console, which says a plus b equals 12. So you can see the console is able to take my two variables a and b and display them as 12 instead of each of their independent variable parts. Visual Studio then prompts me to close the window by pressing any key, and we can continue to build out our application by adding more variables and more methods. So now let's go ahead and allow the user to select the numbers instead of hard coding them to 5 and 7. I'll do another console.writeLine by typing CW tab, and I'm going to prompt the user to type in the first number. Instead of allowing the number to be 5 all the time, I'm going to do a console.readLine to read the input provided by the user. The console.readLine is going to be a string, so I need to convert it to an integer, expecting the user to behave and actually use integers in this example. I'm going to do another console.writeLine asking the user to type in the second number, and I'm going to repeat the code for B, converting to an integer the console.readLine response from the user. Here you may take some time to copy this code if you're following along. And at this point, we can run the code using the Start button at the very top of Visual Studio. Once we run the code, we're going to first get a response from the console for the user to type in the first number. So when we hit run, we see the message, type in the first number. I can type in 5 and hit enter. And then I can see the response to type in the second number, and now we can see that our code is responding accordingly, saying a plus b equals 15 in this instance. Again, we can simply close the console to stop the code from running. Let's do a little more with our console than simply adding two numbers together. Instead of returning the addition of two numbers, let's use our knowledge of loops. So the first thing we're going to do is create a for loop. And in this for loop, I'm going to create an integer variable called b in this example. And in this example, b is going to go from 0 to 10. So here you can see the for loop, int b equals 0, and then you can see the condition by which the for loop continues is so long as b is less than 10. And then you can see each iteration of the loop, b is going to add 1 to its variable size. So if I start the console again, I should only receive the prompt to type in the first number. In this example, I'll type in the number 10 and hit enter. And now you can see a plus b equals 10, 11, 12, 13, all the way down the line because we're adding starting from 0 and going to any number that is less than 10. So the last number that iterates is 9. Let's make this code a bit more clear to the user. Instead of putting a plus b, because the users don't know what variable a and what variable b actually are, let's actually use the variables at hand. So I'm going to put in the variable a, and then I'm going to concatenate that string using a plus sign to put my plus signal. I'm going to concatenate the string again and put my variable b, and I'm going to concatenate the string again to put my equal sign. Final concatenation is to just put a plus b. And if we run this application, you can see how much more clear this is to the user. If we type in the number 7, you can see the addition table added below. We can again close the console to see the code. The concatenation in the string inside the console.writeLine is a lot. We can simplify this by using some built-in methods in the string class. So let's go ahead and clean up this console.writeLine code just a little bit. So we'll comment out the console.writeLine that we currently have, and we'll go ahead and add another console.writeLine using our CW tab. And this time we're going to use a method on the string class called format. So if I type in string.format, the way string.format works is you create your string, and anywhere you intend to put a variable value, you can just put a squiggle brace and then a number in ascending order. And here you can see I can put a where my 0 placeholder would be, b where my 1 placeholder would be, and a plus b where my 2 placeholder would be. If I decide to go up and start and run the program, the application will prompt me to enter a number. When I enter my 7, you see I get the same output as before, but the code looks much cleaner and much easier to read. Now we can close the console in order to stop the application from running. Let's build something a little more generic and a little more useful for all sorts of mathematical operations. Here, I'm going to build a new class that helps me perform different mathematical operations such as addition, subtraction, multiplication, and division. So let's start by creating our class. I'm going to create a publicly accessible class, and I'm going to call this class Console Calculator. After the squiggle braces, I can start to put in my methods. I'll make each of these methods also public so that other classes can use them, because hint, hint, later on we're going to make these referenceable library methods that we can use again and again. And I'm going to create first my add method, which takes 2 integers as inputs and returns the sum of those 2 integers. There is a shorthand way of creating methods this way. I'm going to create another public method that returns an integer, and I'm going to call it subtract. That subtract method is going to take 2 input integer arguments. And now if I use the lambda expression, I can just define what I want my method to do, and it automatically returns that statement. We can create another method called multiply that takes 2 integers as input and returns the multiplication of those 2 integers. And finally, we can create a method called divide. For the divide method, I'm not going to use the shorthand keyword because we want to make sure that we're not accidentally dividing something by 0. So I'm going to make sure that if b is not equal to 0, then I can return the divider between those 2 numbers. And if b was equal to 0, the code would continue past the if statement. And for now, let's just return the minimum double value, but we can make a note to ourselves to handle this a little bit better later. So this will just return the most minimum number that we could possibly have. So to use this new console calculator in our application, we're going to have to create an instance of this class object in the code up above. So go ahead and take the time now to add this code to your project if you're following along. And then we'll implement this code into our project and allow the user to decide what type of mathematical operation they want to perform. So first, let's prompt the user with all the different mathematical operations that our console calculator can support. So we'll ask the user here to select an operation and provide for the user the options to select the different mathematical operations that we've set below. So let's go ahead and add a console.writeLine for add. I'm just going to copy and paste that line a few times, and I'm going to make some new lines for the other mathematical operations, such as subtract, multiply, and divide. Next, we'll determine what mathematical operation the user wants to apply to the number that it's put in. And through that, we'll create an operation variable that's of type integer and use the same console.readline to take the information from the user and convert it to an integer. Now that we have the operation type, we can iterate through which operation type the user has selected. So inside the for loop, I'm going to create a conditional expression. I'm going to create a conditional expression with the if statement. So let's create a new console calculator before the conditional expression so that we can use it inside of each possible conditional expression. And if the operation equals 0, let's call the calculator.add method. We'll put A and B as inputs to this. We'll do the same thing with the operation equal to 1. And if the operation is equal to 1, we'll put the else if here. Then we're going to do the subtract method. So the same thing as before, but this time we're going to call calculator.subtract. We'll do another else if statement on whether or not the user has selected an operation equal to 2. We'll do another console.writeLine with the multiply method, as that would be the number 2 operation that the user can select. And then finally, we'll do the last operation on a divide method. So now we'll do a final else if and a console.writeLine and include the divide method from the calculator. Now just a small change where we'll make B, instead of going from 0 to 10, 1 to 11, just so that we're not always dividing by 0. We don't want to make that happen on purpose. And we'll put a final else statement. Now in this else statement, this would handle if the user put in anything other than 0, 1, 2, or 3. And in this case, we'll tell the user that we were unable to determine the operation because they're not providing an input within the bounds of our expression. So now to run the application and see how it works. Let me make the window a little bit bigger and zoom out a bit in case you want to pause here and copy the code. And when we run the application, you can see that it's asking you for the first number. I'll put 35 and 2 for subtract, or 2 for multiply, and you can see that it's multiplying from 1 to 10, 35. But you can see that the text before that was telling me that it was adding, which is incorrect. So we can make a quick change to the string.format to just represent the mathematical operation that's happening. I'll do a divide this time on 120, and you can see we're dividing 120 by 1 to 10. Actually, when you look at these numbers, these don't look quite correct. If you look at the numbers such as 120 divided by 7 or 120 divided by 9, you know that 120 is not divisible by 7 or 9. Let's go ahead and check that. So 120 divided by 7 should actually be 17.1, not 17. Why is it recording just 17, even though I asked the divide method to return a double? Notice the return type of the divide method is a double. Well, this teaches you something a little bit about mathematical operations in C#. If you perform a mathematical operation between two integer values, it will return an integer value, even if the mathematical operation should not really return an integer value. But it's not going to change the type of two values implicitly without being requested. So if we cast both a and b to a double, we will be sure to get a double back this time. So let's put in 120 for our first number again, or 35, and we'll divide 1 to 10, and you can see now the doubles are getting decimal place numbers. There's no rounding going on because we just left it to whatever the default the console wants to show. Now let's say we wanted to use this code again and again. We've got our 4 mathematical operation methods, and we want to use them in multiple different projects. Well, let's take that same code and create a new project out of it, and this time I'm going to create a project that's of type class library. So if you search class library, you can see that there is a class library type that targets directly the .NET framework. And if you click next, we can go ahead and give our class library a name. I'm going to type in a name here that's representative of my calculator. I'm going to call it console calculator. Or maybe calculator API, just as a hint to how other APIs might be built. And when I create the project, I can copy and paste a lot of the code directly into the project. I've found that this code is useful and I want to reuse it, so I'm going to make myself a short little class library out of it. So I'm going to go ahead and give the class library a name. I'll call it calculator. And then I'll begin to copy and paste some code from the calculator. So you can see that I've added some methods to the calculator. I've added my add, subtract, multiply, and divide method. Now let me show just one more quick and easy feature of building classes and methods. If you create 3 forward slashes above a class or a method, the comment will format itself as you see here. So let me go over the add method again and create 3 slashes, and you'll see that there's a place to put a summary, which I'll put adding 2 numbers. There's a place to put some meaningful description of each of the parameters that go into the method. And the reason you might want to do this is that as other developers are using your code, they'll be able to see by hovering over the class or hovering over the method, not only what that class is for or what that method does, but also what the input parameters are meant to be for that method. And the reason I show you this is that as you begin scripting with the Eclipse Scripting API, you'll see that the Varian developers have provided these types of tools for you. If you click on Start, you'll notice that Visual Studio tells you that a project with the output type of class library is unable to be started in Visual Studio this way. So you can just compile the code by going to the Build menu and choosing the option Build Solution. Now that the solution is built, you can see that in the file system, we've just created our very first dynamic linked library or class library that we can use in a new project. In this next example, we're going to use our newly created class library in a new project. In this project, we're going to build with a user interface. So this time, I'll choose the same option in Visual Studio to create a new project, but this time, I'm going to search for WPF, which stands for Windows Presentation Foundation. Windows Presentation Foundation is a technology by which desktop applications can be built within the .NET framework using Visual Studio. It's more or less a template for how to build a user interface that's already built into Visual Studio. I'm going to select the WPF app that has the .NET framework, and I'm going to call this my calculator app, and I'm going to put this in a new folder and click Create. When I click Create, you'll see that the project template comes with a user interface that I can then modify to match the user interface I want my user to see when they're using it. So in the user interface, this language called XAML is used, that stands for Extensible Application Markup Language. It's pretty similar to like an XML file, but you can change some of these tags and you can see how the application changes accordingly. So if I change the title to calculator, you see the top title says calculator. I can change the height and width to 650 and 400 to make it more of the shape of the calculator app. Now let me show you a little bit about how the XAML works with a couple of examples. So here we have an example stack panel. Inside the stack panel, we're going to have a text block with a name called result, and we're going to set a couple of other properties such as height, margin, and background. Now notice that the stack panel that we have starts with this open caret. And then we put the name of the user interface control that we want to define. And then we do a close caret to encapsulate other controls inside of the stack panel control. And so you can see the text block is another user interface control that starts with an open caret, but this time, instead of ending with a close caret, it ends with a / and close caret, which is just a shorter syntax way of closing the text block. Let's say that you come across a user interface control that you don't know exists. In the upper left-hand corner of Visual Studio, you'll notice that there is a toolbox up at the top. The toolbox up at the top can be selected, and you can notice that you can see a list of all the common WPF controls that are available in building a user interface. And instead of knowing the name of the button, you can simply drag the button into the user interface and begin to change the properties to match what you want the button to perform. So here I'm creating a button with the content of compute. If you wanted to change some other properties such as the name, you can type in a name for that, maybe just compute as well. And if you wanted to change other properties, perhaps you could use the properties window in the bottom right. In the bottom right, you can see the properties window has lots of stuff such as the brush, so you can control the color. You can see the color changing as I click on different colors here. You can also change a number of different categories. If you want your button to actually perform some behavior when the user clicks the button, there is what's called events. And what you're doing when you want the button to perform some event is you're choosing from a predefined list of events, and you can see there's lots of events in the list in the properties window, but the button is meant to be clicked. So if you just double click on the button, you can see an event is created in a C# class file called the code behind file. Now this code behind file is in the Solution Explorer. You actually can't see this file. You notice in the title, the file is mainwindow.xaml.cs. It's actually in a little caret behind the mainwindow.xaml. But at this time, you can see the button click event that we just got from double clicking the button. And when we modify this event, what we can do is we can perform some action on the event. Now, the action that we want to perform for the event, we want to use our new class library to do it. So let's right click on the references, go to Open Reference, and click the Browse button at the bottom and navigate to that DLL file that we compiled in the last example. So here's my DLL file that I compiled in the last example. So as long as I click on Browse and I add this file, you can see that it now appears in the References section. Now that I have this file referenced, I can then reference the namespace. If you remember what I called the namespace, I called the project Calculator API. Now that's going to be the namespace, and this will allow me to use the calculator class that I created inside of that namespace. So just as a simple example, let's go ahead and get a result and set the text property of that result text block, and we're going to set it using a calculator. So to do that, just like the example that we just finished, we're going to create a new calculator class, and we're going to call the add 10, well, it's a comma, right? There's two inputs, so 10, 20, and we're going to convert that to a string and show that in the text block when we run the application. Now when I run the application by clicking Start, you'll see the user interface that has the single text block and the button. And if I click Compute, you'll see the result from that calculator class. So we are able to access successfully the calculator class from the calculator API namespace from the class library that we just compiled in the last example. Now, let's build out our user interface to look like an actual calculator. Now, I don't want to take the time to make this look like an actual calculator. So what I'm going to do instead is use a built-in AI assistant called Copilot. So Copilot is a large language model, and I may have to sign into it. As you just saw, I had to sign in through GitHub, but it is free if you have a GitHub account. And I'm going to ask Copilot here to generate a grid with 3 rows and 4 columns, and the grid should look just like a layout of a calculator, but that last column should have the mathematical operations that a calculator usually has. So just the first 3 columns should have numbers basically from 1 to 9. And then I want to see, the addition, the subtraction, the multiplication, and the division in that last column. So I'm going to tell Copilot exactly this statement. So the more detailed you are with these, AI large language models, the better off they'll be at giving you the code you want. So you can see Copilot gives me a long list of code, and what I can do is I can copy and paste it directly into my text editor, and you can see all these numbers pop up beneath the compute button. Now we can change these numbers very simply by maybe adding a margin to them or giving them a specific height or a specific width to make them look more like buttons on the screen that we would normally see in a calculator app. And so you can, kind of play around with the definition of what the height and the width is for these buttons. Maybe 20 pixels is a little small. Maybe we can go, 40 pixels instead, and that begins to look like a button. So we can take that margin, that height, and that width, and we can just copy and paste it into each of these individual buttons. And you can see all the buttons kind of taking shape with the exact same format. And again, feel free to pause this at any time if you need to copy the code piece by piece. So the last thing we need to do is we need to give our buttons click events, just like we did the calculate button up top. So when we go to give the button a click event, we can also use what's called IntelliSense to provide that click event. To use IntelliSense to create a click event, all we have to do is type in the letter CL, and you'll see CLI, and you'll see the click event appear. And then a menu appears. Notice the menu appears every time I do CLI. And I'm just choosing the exact same method every time, this button click method. Now to get this button click method, the first thing I did was on the very first one, I chose new event handler. So on the very first button, you choose new event handler, but then after each button, you're just going to choose the event handler that already exists. And this is really important because we want every button click to do the same thing. And you're going to see in just a moment what that same thing is. But if I want every button click to do the same thing, every button click needs to point to the same method. So just to reiterate this, when you're using the IntelliSense for the very first button in the list, you're going to choose the option that says new event handler. And then every other time, you're going to choose the event that you created for the first event handler. And look at that, I just accidentally created a new button click _1, and that could be a problem. So I'm actually going to remove that in just a moment. You'll see. When we get down here, we'll remove it. So we're just adding a click event here using the IntelliSense. You should not just type this in. If you type it in, the methods will not actually be applied in the code behind. You have to use the IntelliSense. You have to hit that tab key when you find the button click, okay? So you go in, you say CLI, and then you hit tab, and then you hit, you select the button click, you hit tab again. Okay, let's go back to the event or the code behind here in this main window.xaml.cs file. We're going to get rid of that button click _1. That was an accident. And let's go ahead and say what happens when we perform a button click. Well, I'm going to go ahead and first off say if the result text already contains an equal sign, then let's clear it, right? Because that means that the result has already been calculated. And so we just want to clear it if the result already contains an equal sign. Then what we're going to do with each button click is we're going to add the text from the button that was clicked. We're going to add that text to the result text. So again, Copilot's going to help us out a little bit, but we'll get the result text, and we're going to add to the result text the button from the sender that comes into the button click method. I may mention that the sender is the object that performed the method. And we're just going to add a couple of spaces around the button, just to kind of space it out, and you'll see kind of how the text is defined in some of these spaces. And now when we click compute, we're still going to use the same calculator, but this time I want to know what's in the result text first. So I'm going to parse the result text. What I'm going to do is I'm going to knock off the space at the very beginning of the result text. That's what the trim start does. And then I'm going to knock off the space at the very end of the result text, and that's what the trim end does. And so what I'm going to do is I'm going to make sure that the result text is at least 3 objects long in length, right? So I want to make sure that if I split the result text on a space, which I have lots of spaces, then there's at least 3 of them. And why is that? Because I need a number, space, and then I need my mathematical operation, space, and then I need my result, or my other number to perform the mathematical operation on, right? So I need at least 3 objects. So if I have less than 3, I'm just gonna tell the user it's invalid input. But if I have more than 3, then I'm going to use my calculator. So now that I have the else statement here, which means that there is more than 3 parts to my compute text, which is just the result text, then I'm going to get the first part, and I'm going to call that my first number. And I'm going to get the second part, but the second part I don't really want to convert that to an integer, because that's just going to be the plus or minus or multiply or divide. And then I'm going to get the third part, and that's also going to be an integer. And so finally, what I'll do is, if the second part is an addition, then I'm going to call that result text.add, and I'm going to go through just like I did in the application before, and I'm going to add the first number and the third number. That's what I call it. It is really the second number, but I call it a third num in the variable name. So we're just going to use the same variable name. And now if I do an else if here, I'm just going to do the same thing. So in the else if, I'm going to say if the second part is a minus, then this time just call the result text, and we're going to add an equal sign to it, and then we're going to add the method that the string represents from the calculator app. And you'll see how these methods can just be reproduced here. So I can use the subtract. I can do another else if they put the multiply. Yep, so I'll do multiply. I'll do another else if, and I'll do, if it's divide, we'll put the equal sign, and then we'll call the divide method. Finally, on the else, if there's some issue there, we'll just say, invalid operation or invalid input. Now it's important to have the equals, right? Because when you do the button click, which we have in the method, if the text contains an equals, it just starts over. So anytime you want the app to start over, you can just hit the button and it always adds an equal, and then you can kind of start over. So we don't have a clear button in our calculator, but instead we just add an equal sign every time you click the calculator, and it will add that equal sign. Now let's try out our new calculator, and we'll click the start button to start up the UI. And surely we have not gotten this application to work perfectly the first time around. So perhaps we'll be able to do a little bit of debugging as well. But here you can see the different parts of the application. Again, feel free to pause it as I scroll through. And I'll click the start button. This will open the user interface. We'll see our brand new user interface that Copilot helped us develop. And then we can click any number, and you can see that it's adding those numbers to the result text. And when I click on equals, oh, there's our first crash there. So we had a crash, and when it crashes, you can see the crash message. And you can see the reason why is that my compute parts has the number 1, but it also has a space, and then it has the plus, and it has a space, and then it has the number 5. And so the additional spaces that we're putting on the front and back of all of these pieces of text as we go through, they're having a negative impact on the split method. So we're getting additional spaces in there. So to fix this, and the debug kind of helps us learn this, is we really don't need a space before and after the result text. Let's just do a space maybe before the result text, and that way we don't have these additional spaces in between. So actually, I think I like it better if it's after the result text. So everything's just going to have a space after it, and don't worry, we'll trim it off. That's the first thing we do is trim the text. So I'm going to do 1 plus 5, and that equals 6. And now if I click another number, it just starts it over because the equal sign exists. And remember, we asked it, if the equal sign exists, start the text over before adding the next button. So I'll do 9 divided by 3. I'll hit my compute, and you can see that equals 3. And so now we have a calculator that relies specifically on an API that we've built through a class library in C#. And this kind of completes the circle of how you can build class libraries to use over and over again in C# projects.
So now, to bring it all together, let's review quickly what we've done so far. So far, we've looked at the syntax of C# in the .NET Framework programming environment. We've also looked at downloading, installing, and using Visual Studio as an integrated development environment. During the demonstrations, we first created a simple console app to simply just add numbers together, subtract numbers, and just show to the user some different mathematical operations. Since we liked the way our mathematical operation methods were working, we decided to create a class library of those methods. We compiled that class library into a DLL file, created a Windows Presentation Foundation project with a user interface, although the user interface was mostly built by GitHub Copilot, and then we integrated our class library into a new Windows Presentation Foundation user interface project. Now that sounds like a lot, but remember this is your first time, maybe your first time seeing this workflow. So why did we do all that? Well, let's talk about how we can bridge the knowledge that we just saw into how the Eclipse Scripting API works. So remember, the Eclipse Scripting API is a set of really two class libraries that Varian programmers have developed in order to give you access to methods, properties, and services inside of the Eclipse treatment planning system. So now we're going to apply our C# and Visual Studio knowledge to what we can learn from the Eclipse Scripting API. Within this presentation, we're going to do a quick overview of how to generate Eclipse Scripting API applications. We'll look at the different types of ESAPI applications that are available in Eclipse. We'll look at a quick code review of the types of code that you will usually see in an Eclipse Scripting API application. And then we're going to prepare for our ESAPI introduction course and how we can get ready for and then we're going to apply our knowledge for how we can prepare for the ESAPI introduction course. When you generate an Eclipse Scripting API script, you can generate it in two different ways. You can use the Eclipse Script Wizard, which has lots of built-in different types of scripts such as a single file plugin, binary plugin, standalone executable, and more. Or you could decide to forego the Eclipse Script Wizard and just use Visual Studio to create your project. Now for the beginner, I would certainly recommend using the Eclipse Script Wizard. The Eclipse Script Wizard is going to create applications that are ready to develop against Eclipse. Where in Visual Studio, you're going to have a couple of types of projects and also project settings that you're going to have to get right in order to use it against Eclipse. So let's first talk about the types of projects that you would create in Visual Studio in order to communicate with Eclipse. If you're creating a plugin script, whether it's a single file plugin or a binary plugin, you want to create a Visual Studio project type called a class library. Now we saw this in a couple examples ago, how to create a class library, but we're going to create it slightly different if you want to create a plugin script. If you wanted to create a standalone executable, Eclipse supports communication through application types in the .NET framework of both Windows Presentation Foundation and console applications. So it just depends on what type of application you're trying to create. Now a couple of notes if you do decide to use Visual Studio for the application creation is that you will have to add references to the ESAPI libraries manually. So to do that, remember you would right-click on the References section in the Solution Explorer of Visual Studio. You would go to the Browse menu. You would click on the Browse button, and you would navigate to where the ESAPI libraries are installed on your development environment. You would select both of these libraries and click OK, and you would add them to the project. Additionally, in the project properties, which can be accessed from the project menu bar at the very top of Visual Studio, and going down to the name of your project, properties, you can see a build menu on the left-hand side, and the platform target for all Eclipse Scripting API apps must be x64. Now, if you decide to use Visual Studio instead of using the Eclipse Script Wizard, you will need to do these steps yourself. If you decide to use the Eclipse Script Wizard, these steps will be performed for you by the Eclipse Script Wizard. That's why it's really recommended for beginners to start with the Eclipse Script Wizard. Now let's talk a little bit about the popular options for Eclipse Scripting API application types. We first have the single file plugin. A single file plugin is a single file of C# source code that has the proper template for a plugin as defined by the Eclipse Scripting API, and then you're going to run the script from inside of Eclipse. So you're going to go into Eclipse, you're going to click on the Tools menu in the External Beam Planning workspace, and you're going to go down to the scripts option in the tools menu, and you're going to find your plugin script, which is going to end in an extension of .cs, and you're going to run that script. But keep in mind, it is just a single file. The binary plugin is not a single file, but it's multiple files that you can compile into a DLL. Stands for Dynamic Link Library. We saw that before. You're creating your own class library with one or multiple programming files. This application is also run inside of Eclipse in the same way as a single file plugin. Finally, there's a standalone executable. A standalone executable is an application that ends in the extension type of exe. It can be either a console application or a UI designed application, and these run directly from the operating system, mostly by just double clicking the icon that's provided when the code is compiled. Each of these different applications has its own benefits and its own drawback. For instance, the single file plugin is very easy to set up. It's just a single file. You actually don't need Visual Studio any integrated development environment to build it. Although Visual Studio does provide a lot of tools that makes it easy, it's not really required. You could build a single file plugin in Notepad if you wanted to. So it's really easy to build, it's really easy to get started, and it's really great for testing basic scripting functionality. If you wonder how a method works or how a property results, you can build a really simple single file plugin to run that method or access that property and display the result. The drawbacks to a single file plugin, it's really difficult to build a user interface with a single file plugin. Single file plugin, it's it's not like the XAML file where we can build a large user interface very easily inside the C# code directly. Usually user interfaces require more than one file. Single file plugins are also missing some basic functionality in the .NET framework. That's because the compiler inside of Eclipse is usually 1 to 2 or more versions behind in the version of C# that it uses versus the version of Visual Studio that you might be using. Secondary, there's a binary plugin. The binary plugin is similar to the single file plugin is that it runs similar inside of Eclipse. So it launches easily from Eclipse. It feels like a script should feel. The binary plugin is generally made of one or multiple files, so it very much so supports building user interfaces. One thing that could be considered a drawback from a binary plugin is that when the user runs the binary plugin, Eclipse is inaccessible during the run of the binary plugin. This is by design. Sometimes this could be useful. For instance, if you build a binary plugin that modifies data about the patient, perhaps you don't want the user to also be able to modify that patient data within the external beam planning application. Then you could run into an issue where the same user was modifying the same thing twice. Finally, we come to the standalone executable. The standalone executable can utilize all .NET Framework functionality because it doesn't rely on Eclipse at all. It leverages Eclipse, it connects to Eclipse, but when you build it, you're not running it from Eclipse directly. So think of it as building something completely standalone, and you can use the technologies that are afforded to you by Microsoft through the .NET Framework. You can easily reference third-party libraries for your code. You can build out the application to look really nice. You can use templates. It's very easy to integrate resources into the application. The only drawback to a standalone executable is that there's extra steps to launch it from Eclipse. Because it's an executable, the user will have to go and find it and launch the executable. And that executable will have to exist on the same system where it can find the Eclipse treatment planning system to be able to leverage the Eclipse scripting API. So there's some difficulty in how you actually get it to run. Let's take a look at some very basic and available code samples for both plugins and executable scripts. The plugin script, as you see on the left, usually has an execute method that's built into the template. Inside of that execute method, there's going to be a script context class object with the variable name of context. This context is something that's provided by the Eclipse scripting API. The idea here is that Eclipse, the treatment planning system, is going to pull in your plugin and it's going to run this execute method. And when Eclipse, again, the treatment planning system, when Eclipse runs that plugin, it's going to construct its own object called a script context, and it's going to call it context, and it's going to pass it into your script. And now you as the developer, you need to preemptive that call and the creation of that context variable and tell Eclipse what to do with that context variable, which represents pretty much everything that you have open inside of external beam planning at that moment. So you can see how we can easily get the patient from context.patient. You can see how we can access all of the plans from the next line in patient.course.plan setups. Now these are properties on the patient object that we've just created from the context. And then you can use C# to create something like a string builder. You can use a for each loop, which we talked about the syntax of that earlier. And you can provide a message box to the user with some information about the patient and the plans. For a standalone executable, the code looks a little bit different. In a standalone executable, the execute method takes an application. This application object is an instance of the external beam planning workspace. So it's as if a new user has just logged into the external beam planning workspace, and that user is the person running the script. You can access the patient instead of accessing it from the context because, again, the standalone executable doesn't know which patient you might have open in Eclipse. It's as if it's opening a new. And so there are methods such as open patient or open patient by ID on the application so that the user can provide a patient ID and open the patient. Once that patient is open, it behaves very similar to the plugin. Now that the patient is open, you can access courses, plans, and more from the patient. Remember to close the patient after you're done. As you prepare for the Eclipse Scripting API Introduction course, keep in mind that we're going to take the C# knowledge that we've learned and we're going to apply it to real-world script examples. So scripts that you might actually want to run in your clinic. We're going to talk about the types of methods and properties that are available in the Eclipse Scripting API. We're going to use the C# syntax that we've learned to leverage the Eclipse Scripting API and perform more programmatic operations with it. We're also going to build scripts of different application types, such as plugin scripts and standalone executables. Finally, we'll also build functional user interfaces with the Eclipse Scripting API. Hopefully, this series of videos was helpful in showing you how to use C#, Visual Studio, and preparing you for the types of things that you might see and the types of terminology that you might hear during the ESAPI Introduction course. We look forward to seeing you in the ESAPI Introduction course, and we appreciate you watching these videos.